So in the previous couple of videos, we talked about variables, literals, and operators, which are all ways that we can create expressions to compute certain values and do a little bit more with our code than in our previous versions of code where we were just calling all these other functions to turn on and off lights and stuff like that. We're able to do a little bit of math here now, and we don't have to do the math. We can kind of outsource that to the Arduino, which is nice. So now that we kind of know how to do that, let's talk about analog inputs. And so if you remember, if we go to our camera view here, we have the 6 analog inputs over here on the left side labeled A0 through A5. And what these can do is give us an analog reading, meaning they're giving us a range of different values where the digital pins can just give us a value that's either on or off. Here we can get a range of different values. So let's take a look at how we can wire this up and what it takes to read an analog value with code here. All right, so let's go back here, and yeah, the Arduino Uno specifically has 6 analog inputs, and it uses something called an analog to digital converter to convert analog values. Because like I said, computers in the Arduino are digital things, so it's not really a true analog value, but it gives us a little bit more granularity than just on or off. So specifically, this analog input can give us a range of 1,024 different possible values. So it's not perfect. It can't give us a bajillion decimal points of what it's actually reading, but it'll give us some information. So what happens is when we use a function called analog read, it's going to return back a value. It has a return value, which is our first function that we're using that does have a return value. And it's going to return some value between 0 and 1023. And so it might seem weird because what I said is we could read a range of voltage values, and the maximum voltage value that we can read on here is 5 volts. If we try to read more than that, we could damage the chip, so we want to make sure that we're only reading stuff up to 5 volts. But basically what we can do is like a unit conversion to rescale that. So if we take whatever value we read here, where it's something between 0 and 1023, and we multiply that times 5 volts and divide it by 123, which is the maximum number of different values we could read, we can get our like the rescaled voltage value, right? So that's what we're going to try to do here. So let's take a little bit closer look at how analog read works, right? So since we're using the analog input pins, and by default they are analog input pins, we don't need to use pin mode to set them up. So previously when we were using the digital write on our digital pins to output something to like an LED, we had to use pin mode to say, hey, set it up as an output. In this case, we don't need to do that. There's nothing required in setup for reading that. All we're going to do is just read the value. And so analog read expects one input argument, one value that we're going to supply to it inside of its parentheses, and that is the pin. And we just need to tell it something between A0 and A5. And what it's going to do is return to us an integer voltage value, or an integer value that's between 0 and 1023. And then if we want to scale that to a voltage value, we can do that. Okay, so let's go through and set this up here. What we're going to do is let's start with the circuit here. All right, so we'll flip over to the camera. And so here's my Arduino. I'm not going to power it up, but we're bringing back our breadboard here. And we are going to read the wiper pin of a potentiometer. So remember, it provides a constant resistance on its outer 2 pins, but the middle pin goes across the resistive material and changes its resistance as a proportion of where it's located along this. So what we can do is we could hook up one end of this to 5 volts, one end of this to 0 volts, and then the wiper pin will be something in between 0 and 5 volts based on where it's located, and we'll be able to read its value very precisely using the analog inputs here. So that's what we're going to do. So I'm going to just plug this here with like each one of the 3 pins going into a different row, and I'm going to use this red one to indicate that this is going to be like my red positive 5 volts. So I will go to the 5 volts. And I'm going to use black to indicate that it is the like negative or 0 volts. So I'm going to connect that here to ground on this side. So we got 5 volts in ground. And then I'm going to use this middle orange wire here and have this powered off so that when this is accidentally touching other things, it's not damaging it. So this middle one is going to go, let's just go to A0 for starters. All right. And so that should be all that we need. So now what I'm going to do is I'm going to power this on by plugging it up to the USB, and we'll switch back over to an editor here. And I just have kind of our blank template up here. All right. So we're going to start kind of the way that we customarily do by creating a macro. We're going to say pound define. And what I'm going to do is we'll just call this, pot for potentiometer. And we're going to say where it's connected to. So in this case, it's connected to pin A0. So we need the capital A and then 0 so that it recognizes that we're talking about analog pin 0 and not digital pin 0. And then inside of here, we don't need to set up the pin mode for analog pins because they are by default analog inputs. But one thing that might be helpful is we're going to be reading these values, but we'll want to be able to see them. So let's bring back the serial port here so that we can use it. So I'm going to say configure serial port. And remember, that's going to be serial with a capital S dot begin. And then we say 9600, which is the default value here. And then it's set up. And so now what we can do is let's go into loop so that it continuously reads the value from there. All right. And so we need to declare a variable here. So I'm going to say int, and because what it gives us is some integer value between 0 and 1023. And so I'll just call this int wiper, let's say, and it's going to be set equal to analog read. And specifically, we need to tell it what pin we want it to read, and that's going to be called pot. And the reason why we're putting that function on the right-hand side of the equal sign is it returns something here. So we see that it says int analog read. What that's telling us is that it's returning some integer value, and what we're going to do is take the value that it returns, that's something in the range of 0 to 1023, and storing it here inside of this variable. Okay, so this is reading the analog input pin, and then let's just go ahead and print this out. So send to PC. So we're going to print this out here and just see what it looks like. And I'm doing Java there, the serial.println, and then I can just say the name of the variable here. If I just put the name of the variable inside of the parentheses here as the argument that I'm passing to serial.print, what it's going to do is it's not going to print the word wiper, it's going to print the value that's stored inside of that variable there. If I put this inside of quotes, it would no longer interpret it as code, and it would literally just print the word wiper in the serial monitor. But if I do it like this, that should be fine, right? So I'll save this as like analog, and it's going to reload. And then what we'll do is we'll try to compile it, make sure that there's no errors, and then see if we get some information back. All right, done uploading. So let's do this. All right, so we're seeing some values here. Let's see if this works. All right, perfect. So we're seeing a very high value here. So let's see, as I turn this dial now to the right, we're seeing it start to lower, which is great. Let's see if we can get it close to 0. Oh, we got it all the way to 0. And if I bump it all the way up, let's see if we can get it all the way to its max. Almost. It's like almost 10. Oh, I can see sometimes it's hitting 1023. So yeah, it's about at the max there. And so yeah, we can see that we're scrolling through these different range of values. And again, it gives us some integer value that's between 0 and 1023. It seems kind of odd, but 1023 is 2 to the power of 10 is 1024. So what it's doing is it's saying we're representing this value as a 10-digit binary number, or a 10-bit binary number. And so that's why it's kind of that weird number there. So like I mentioned earlier, if we want to rescale this to a voltage value, we can do that. So let's try and rescale it to a voltage value here. So what I'll do is I'm going to close this for a second, And if I want to comment out a line, like I don't want this line to be there anymore, but I don't want to delete it entirely, maybe I'll want it again in the future, I can just hit Control/ while I'm on that line, and it automatically makes it a comment. And then I can hit Control/ again, and it makes it not a comment. So if I want to bring this line of code in and out of the program, that can be a really helpful thing to do. So right now I'm going to comment it out, and I'm going to create a new variable here called voltage. But remember, to declare a variable, to create a new variable, I need to give it a type. And what we want to do here is represent some value between 0 and 5, but it could be a decimal value. So I'm going to change this to be float. And what I'm going to do is I'm going to set it equal to wiper. And then what I need to do is multiply it times 5.0. And it might seem weird that I'm doing this 0.0 here, but this is going to force all of this to be converted to a float value so it doesn't accidentally do some rounding and drop off the decimal point here. So I'm going to say multiply by 5, which is the max, like we're doing our unit conversion here. So 5 is the max value there. And then I'm going to divide it by 124.0. Again, I'm doing 0.0 because we're dealing with floats. So I just add that decimal point to make it very explicit that we want a float value. And now let's try printing out. So I'll say serial.println voltage and see what we get here. Let's see if we get a voltage value that corresponds between 0 and about 5. So I'll scroll up so you can see that. It's uploading, it's uploading. All right, so we're at 1.6. So we're somewhere in the middle. If I go all the way down, we hit 0. If I go all the way up, yeah, we're right at 4.99 or 5. It's kind of toggling back and forth. So yeah, now that's working perfectly. If you are ever like returning just a numerical value, there is another option here. You can hit serial plotter, which brings this up and it plots these values on a graph over time, right? So as I scroll it down, we can see it change. As I scroll it up, you can see it change like this. So sometimes that can be helpful based on whatever you're doing, or sometimes you might just want to use the serial monitor. It's up to you, but both of those options are helpful. But yeah, that's basically the gist of how you do analog read and why it's helpful to be able to use variables and be able to do a little bit of computation here based on what values you're dealing with.